Greetings. Welcome to the Interplanetary Networking Special Interest Group's Academy keynote for February. My name is Jim Schier. I'll be your moderator today on the subject of interplanetary networking governance. So I'm the chief architect for NASA's Space Communication and Navigation Program. I work out of NASA headquarters where I lead NASA and international studies that define not only NASA, but the international architecture of communication, networking, tracking, navigation capabilities across multiple space agencies where we have several different forums for doing that kind of coordination. Ultimately, that translates into our action plans and eventually results in updating our networks with new capabilities that enable us to provide cross support. In other words, to interoperate with other space agencies. We're working right now on the evolution for the moon with the Artemis program and science programs to send more science payloads to the moon. Accompanying that, we're starting to establish what's going to be known as the Lunar Network, or the LunaNet. And so one of the activities that I lead is I co-chair the International Committee to study LunaNet governance, and therefore I'm directly interested in what Dr. Laura DeNardis is going to be talking about today. So I'm pleased to be able to introduce our distinguished speaker. But first, I should mention that this event is being recorded, and ask you to, if you have questions, this is an interactive session, so we welcome your questions. Please put your questions in the Q&A panel as opposed to the chat panel. We'll be taking questions in real time during the presentation as well as afterwards. So with that, let me introduce our speaker today. Dr. Laura DeNardis is a professor and endowed chair in technology, ethics, and society at Georgetown University. Professor DeNardis is recognized as a leading internet governance expert in both the United States and the world. Wired UK recently named her one of 32 global innovators who are building a better future, and her book, The Internet in Everything, Freedom and Security in a World with No Off Switch, published by Yale University Press, was recognized as a Financial Times top technology book of 2020. Among her 7 books, The Global War for Internet Governance, oh, sounds ominous, also published by Yale University, is widely considered the definitive source for understanding power struggles over digital infrastructure. So Professor DeNardis is a senior fellow at the Center for International Governance Innovation, an affiliated fellow of the Information Society Project at Yale Law School, where she previously served as executive director, and is a member of the Council on Foreign Relations. She holds an AB in engineering science from Dartmouth, a Master of Engineering from Cornell, a PhD in science and technology studies from Virginia Tech, and was awarded a postdoctoral fellowship from Yale Law School. With that, let me turn it over to Laura. Laura, it's all yours.
Thank you so much, Jim, and hi, everyone. It's really great to join you today as part of the Interplanetary Networking Special Interest Group Global Academy and discuss interplanetary internet governance. I want to begin by addressing the elephant in the room. Is it too soon to think about a solar system internet, and even far more too soon to think of the governance framework around a solar system internet? Well, history tells us that it is not too soon to think about the internet in space. And if you go back in history, we can learn about the future. History of the internet tells us that it really is, it recently turned 50. If you view its inception as the late 1960s American milestone, when the first packets were exchanged among 4 nodes over ARPANET. So note the hand-drawn picture of ARPANET here on the left-hand side of the slide. What was happening in the world at that time? In 1968, the Vietnam War was raging, and a gentleman by the name of Gordon Moore founded a novel technology company in a part of California, a sleepy part, that would later be called Silicon Valley. The founders of Google and Facebook both weren't even born, and NASA was still preparing the Apollo 11 mission that would attempt the first lunar landing in history. So at the same time, the beginning of internet governance, it wasn't called that at the time, but it started fomenting in different ways, including the first coordinating body, the Network Working Group, which was convened to develop protocols for communicating over ARPANET. And then that same year, Martin Luther King Jr. was assassinated. So all of this happened, while it seems like a long time ago, all of it happened in my brief lifetime. But for those like my students who view that as a half century as way too long, well, what was happening a quarter century ago? Web browsers only date back to the 1990s. At that time, there was no Facebook, Google, certainly no TikTok, smartphones, the IoT, or streaming video. So the pace of technological change has been stunning as the internet has diffused into every corner of the earth, around the planet's atmosphere, and into material objects, and even into the body. So is it too early to think about the next half century? Definitely not. So the way I like to think about this is that it's very likely that the internet's next chapter will lie in both infinitesimally small and astronomically large spaces. I addressed the small spaces in my book, The Internet and Everything, but today we are discussing internet governance in the large spaces, a solar system internet. So this actually has a longer history than most people think. Internet pioneer Vint Cerf was already broaching the subject of an interplanetary internet at an ISOC meeting in Geneva in July of 1998. Indeed, early thinking on the interplanetary internet began at that time. I think he was at the Jet Propulsion Laboratory at the time as a distinguished visiting scientist. And I recently, in looking over NASA documents, saw that there was a very interesting Pathway to the Future presentation that NASA Administrator Daniel Gold gave in 1999 at NASA's Langley Center that futuristically mentioned a space station, a Mars plane, and yes, interplanetary internets, plural. So this vision is really remarkable in the time before most modern internet applications. Now, there are, of course, many initiatives in space already using communication networks, such as the Deep Space Network and others. So many things are happening. Most of these involve point-to-point communication between Earth and spacecraft. And while the idea of the solar system internet it's very different from that point-to-point, it's more about store and forward packet switched mesh design that connects many nodes and potentially many different networks. So similar to early ARPANET, it may be not possible to envision the uses of such a network, but nevertheless, we want to envision the uses. It will no doubt include support of discovery and exploration in space, support space stations of the future, have many commercial uses eventually, possibly even around human space travel, and inevitably, of course, national security and intelligence applications. So if it's not too early to think about this technical architecture, then it's really not too early to think about governance concerns. So I like to start always when I talk with the conceptual framework around all of my research, and that's that arrangements of technical architecture are also arrangements of power. My work tries to I would call it de-black box. It's hard to say that. I do the de-black boxing of emerging technologies and try to examine the social, the political, and the economic implications of how these technologies are designed and governed. So I've done that most recently around quantum internet protocols and the Internet of Things, which was addressed in one of my recent books, and also for a long time now, emerging infrastructures of internet governance as they have developed over time. So this is why most people describe me as an internet governance scholar, and I feel it's important to say a little bit about what this term means. these are issues of internet governance, even around emerging technologies. And I generally define that as the design and administration of the technologies that keep the internet operational, and then the enactment of policy around these technologies. And many people share that definition from something like that from the United Nations to ISOC to ICANN. So it's not a controversial definition at all, but it does make 3 quick points about internet governance that I'd like to elaborate. The first is that it's about design and technical coordination as much as it is about what we think of as policy and regulations about the systems once they're developed. Second is that there's not one issue called internet governance, despite how the media sometimes discusses it, but numerous functions from standard setting to the administration of critical internet resources to interconnection arrangements that are largely private. Certainly the public policy role of private information intermediaries is a big part of it. And then also government regulatory structures, which brings me to the last point I'd like to make about setting up a framework for how capacious and almost unique this issue is. It's an oxymoron. I called chapter 1 of this now almost 10-year-old book, The Global War for Internet Governance. I called chapter 1 the Internet Governance Oxymoron because it's not just about governments. The various functions coordinating and establishing policies around the internet are distributed across many actors, private companies, global technical coordinating institutions, standard setting institutions, nation states, international agreements, and sometimes even civil society. So some of the functions involve one actor, some involve many actor classes, but collectively, this broad ecosystem is usually called multi-stakeholder internet governance. My talk today is really about anticipatory governance. So examining the points of design and coordination before emerging technologies become widely entrenched. So that's a very interesting enterprise. And I'll just begin by saying, what are some of the anticipatory governance questions that are important for an interplanetary internet? The overarching question is what governance functions, and while we can't say geopolitical, so I just threw in there heliopolitical frameworks, will be necessary to design, to administer, and to secure an interplanetary communication future for the good of all. So I think this breaks down into 4 parts initially. So one question is about the unique constraints of space that will shape design and governance. So in other words, what are the unique technological affordances, natural affordances, and governance complexities that will shape interplanetary internet architecture and governance? Another question is about existing space governance frameworks. What are the space governance frameworks and treaties that now exist, and what is their relevance to deep space ICPs? The third question is, to me, the most interesting one, and it's about the applicability of terrestrial internet governance to space. What are the core layers of internet governance on Earth that are likely to extend and apply in deep space, which don't apply, and what might be missing? And finally, what lessons from Earth internet governance, if we can call it that, can help inform structures of interplanetary internet governance? So I want to say a little bit about, it's just such an interesting topic. What are the deep space challenges to internet design and governance? What are the unique contexts? Well, there are many interesting ones that will shape cyber governance in the same way that it will shape the technical architecture. I've been reading through a lot of interesting things. One was the NASA's, I can't remember the exact name, the Orbital Debris newsletter, and noticed in one issue that on November 15th of 2021, the Russian Federation shot down a Soviet-era spacecraft that had been launched in 1982. And while the first concern, there's a meeting in Geneva going on right now related to space governance. The first concern there might be direct ascent anti-satellite or ASAT missile testing, how that's a national security issue. But there's another issue. The US Space Surveillance Network identified more than 1,500 pieces of large trackable fragments from the breakup. So you may have seen the Disney movie WALL-E and remember its memorable scene about space debris. And I couldn't resist putting a picture from that scene in the upper left-hand corner here. Some might remember it. When WALL-E, the robot, launches into outer space, his rocket has to smash through a thick blanket of Earth orbiting satellites and copious space debris. And this crowd, if you did see the movie, you probably would have noticed Sputnik 1 among the blanket of Earth orbiting debris, and it gets stuck on his spacecraft. So I just love that. But although Sputnik actually disintegrated into Earth's atmosphere in 1958, this issue of space debris, human-made and also natural, it's a growing problem, hurtling along at rates sometimes measured in miles per second, and always a risk to the ISS, to rockets and satellites. So what this means is that the possible disruption associated with this has to be anticipated and addressed in fault-tolerant approaches, resiliency in the architecture, redundancy, new forms of error detection and correction, and political and industry attention to tracking. Another one that's incredibly interesting, and the standards experts are doing such interesting work on this. It's the subject of other lectures in this series. The astronomical distances. These long distances will require solutions to latency and solutions to packet loss, and prompt new architectures with greater autonomy, greater local processing. So that's an incredibly important constraint. Natural disruptions, as you can imagine, are also a factor. Solar flares, space weather, asteroids, and harsh atmospheric conditions in space. This will really require a lot of architectural changes that favor resiliency, that favor stability. So these are there are volcanoes and undersea cable problems and earthquakes on Earth, but it's a whole different magnitude in space. Planetary motion is a factor. That's a really interesting one. The movement of planets and their satellites will create constantly changing transmission distances and intermittent disruptions. That has to be addressed. Space ICT components, interestingly similar to the IoT, but also more complicated. They're constrained resources in that they'll require renewable power sources, sometimes small power sources, and they're resource constrained in terms of upgradability and maintenance of parts. So I want to mention two more of these challenges and constraints that are even more different from the Earth Internet. Coordination requires a lot of synchronization, but the time synchronization required for network transmission is really challenged by questions about what time is it in space, by time relativity, such as different gravitational conditions affecting clock speed. For anyone interested in that, just look for, there's been a spate of recent articles and attention, like what time is it on the moon? What time is it in outer space? I remember a book years ago by Stephen Jay Gould, I believe it was, questioning the millennium about the relativity of time. This is an issue in terms of the design and the governance. And then, of course, the more political one, sovereignty, is upended. Sovereignty is already disrupted in many ways by the Earth Internet and the Earth Internet governance systems that cross borders, and also disrupted by the privatization of governance in this sphere. But the absence of territorial boundaries in space will challenge sovereignty and jurisdiction and tech jurisdiction and require different kinds of negotiation and cooperation. So indeed, there are pragmatic and legal limits to nation state control or ownership in outer space of the technical systems of internet governance. So that is, those are the ones that I think are most relevant to challenges in the architecture and the governance. Which brings me to the second big question. What is the current space governance context, and does it apply to deep space? There is a space governance framework, a constellation of laws, treaties, and alliances, many of which arose in the context of the mid-20th century space race between the US and the former Soviet Union. So in that Cold War context, very few nations had any programs for space exploration. I guess it was 1957, I believe, when the Soviet Union launched Sputnik. Just a year later, the United Nations Office of Outer Space Affairs, or the UN's USHA, as it's called, was launched. So that followed very closely. And their Committee on the Peaceful Uses of Outer Space is the UN Forum for International Treaties historically, and for principles on space-related activities. I've included the main five here, what is rightly called the foundational United Nations space treaties. And I'll just make a few notes on these. I couldn't resist putting a picture of one of the first interface message processors on those original nodes around ARPANET, because the Outer Space Treaty was enacted at the same time as the IMPs were developed. So that puts it in a lot of perspective. But the formal name of that treaty is the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies. So this treaty indicates that space exploration and use should be for the benefit of all. It should be open to all states for exploration and not subject to sovereign appropriation. And part of this treaty is that states agree to not place nuclear weapons and other so-called weapons of mass destruction in space, and to use the moon and the planets for peaceful purposes. So originally signed by the US, the UK, and Russia, the Soviet Union, more than 100 countries have since become parties to this treaty. So there are others that have materialized since then. The Rescue Agreement is certainly one of them. It's an agreement to mutually render assistance to astronauts in distress. I want you to listen as I'm talking to see if you hear anything about information and communication technologies. This is about returning the astronauts in the event of an emergency, landing, and the return of space objects. The Space Liability Convention from 1972 is about international liability for damage caused by space objects, essentially holding nation states responsible for any damage that is caused by a space object, including those launched by any party within that nation's territory. Then there's the Registration Convention, also in the 1970s, which is essentially a tracking agreement requiring registration of objects launched into outer space for various purposes. That word tracking is quite different than we use in the cyber realm. So it doesn't mean real-time tracking. It's really just a registration of orbital and functional details around these objects. And then there's the Moon Agreement. I couldn't resist putting a picture that it's not my actual Apple Mac from 1984, but it's the same kind. My first Apple Mac I got in 1984 at the same time as this Moon Agreement, which lays out numerous provisions about the moon, such as prohibiting rights of ownership, calling for lunar resources not being subject to appropriation, or various kinds of conflict, and a commitment to environmental protection, among many other provisions. Now, many of you might know that this treaty has not been signed by many of the major human spaceflight countries. So that's something to keep in mind. This is a very brief snapshot, but how does this overarching space governance framework apply to the interplanetary internet is really the question that is of interest to me.
Laura, if I could insert, we have a question in the Q&A panel from Nicholas Fiumarelli. He would like to know whether after the first After the recent discussions on quantum communications at the last IGF in 2022, what is your opinion about the issues or implications of quantum internet principles for the deployment of interplanetary networks? There is a lot of work going on in the QIRG mailing list at the IETF and at the RIR level with the quantum internet hackathons. To what extent can these two technologies articulate? Can they perhaps be mutually beneficial?
What a great question, and I appreciate that you interjected with that. I actually just did a major research project on quantum internet protocols, which was funded by the National Science Foundation through the University of Arizona. And I would be happy to send that to you. It's called Quantum Internet Protocols. I would say that if quantum communications or even quantum is not one thing, of course. There are many different applications of that, sensing, communications, many different applications. But just speaking to the internet environment for a moment, you have the quantum computing threat to encryption systems, and in particular, the public key cryptography systems that run many of the basic functions that keep the internet in various trust architectures. You also have the efforts to shore up the algorithms. NIST is doing a lot in that regard to shore up algorithms from projected future attacks from quantum computers, should that happen. And then you have innovations happening in end-to-end quantum communications, which is far into the future. So that is very, very nascent on the Earth, and it's even more nascent in space. So how those two come together, I think, remains to be seen. Which one will, they'll come hand in hand in some ways. But there are maybe some possible applications of quantum communications that could be helpful to tackle some of these problems. So that's an important issue to bring up, and I'm glad you did. The question, yes.
I would add one thing to that. We have a quantum technology initiative within the Space Communication and Navigation program at NASA looking into these very things. And one thing that we're expecting is that quantum will ride on top of optical communications. So we have an even larger program of developing laser communications technology. We have already demonstrated that to the moon with a lunar laser comm demo back in 2013. We've demonstrated 600 megabits per second data rate from the moon. And we have an upcoming experiment on the next Orion Artemis program launch, and that will ride on the Orion spacecraft. One thing to note about quantum is that it will follow the introduction of optical communications in space.
Right, and this is just a perfect segue into what I was about to say, and that's, when you ask the question, and at least through the lens of an internet governance scholar, there are many aspects of this that are really not easily applicable to the digital domain or the quantum domain, should that be an overlay with digital technologies, or the cyber domain in general. Technology constantly changes, and the international treaties predate most internet technologies, including the World Wide Web, and they don't overtly address information and communication technologies in the same way they would, I think, if developed today. They also predate mass, and this is a really important one, they predate mass satellite proliferation for applications on Earth and our strategic dependency on these satellites here on Earth, including I would be lost without my GPS, transportation, financial transactions, weather, television, and internet access, among other functions. They also predate terrestrial national security dependency on space systems, whether that's including real-time monitoring and command and control networks. So obviously we now have a US Space Force, and we've got the rebranded French Air and Space Force. So space is an operational domain for NATO. It's considered a domain of warfare. This is very different. And then you of course would have noticed, and Jim, I just want you to feel free to interrupt as questions come in, if anything, or if you want to add anything. But most of these participants would notice they're multilateral, not multi-stakeholder, naturally focusing on nation states only and not directed at private actors. So this is not surprising, and in part because the treaties predated commercial space programs, and they certainly predated what we call the multi-stakeholder governance model around the internet. I wanted to really briefly mention, and it's important to note that there are a number of bilateral and multilateral agreements that have emerged in the contemporary moment, including most recently, I just put something from a few weeks ago there, January 13th, 2023, when the US and Japan signed a framework agreement for cooperation in the exploration and use of outer space. So Japan and the US were also two of the initial 8 signatories on the Artemis Accords, and also partners in the Artemis program to return astronauts to the lunar surface. And Jim, feel free to jump in there if you'd like to, with your work working on lunar networks.
Yeah, so we're clearly involved in the Artemis Accords that you identified here, and so I think the first point to make there is to recognize that the work at the UN COPUOS continues, but over the decades it's proved to be less and less feasible to get broad acceptance at the international treaty level. And as a result, the U.S. State Department, working with NASA, have started this approach that results in the Artemis Accords, which is an attempt at soft policy, soft international diplomacy. So the Artemis Accords state a set of 10 principles, and you've identified the key one relevant here, which is interoperability. We can't establish an interplanetary internet with many actors, many countries, many companies, and many academic institutions without having interoperability between the various network aspects. And so that we're putting in place Artemis Accords as a way of establishing international norms of behavior. And so we're continuing to promote the Artemis Accords. So far, we've been successful in getting 23 countries to sign bilateral agreement to accept and implement the Artemis Accords. But think of that as just a first step in the direction of what will ultimately be needed.
Thank you very much for that, Jim. I really appreciate that. And thanks for pointing out the interoperability section of the Artemis Accords, which is, of course, relevant here. So this leads me into the third area, the third question, and that is, to what extent does a layered taxonomy of internet governance on Earth apply or inform the possible trajectory of governance of a solar system internet? And this is something that, there are many different ways to address this. I think if someone else were sitting here in my seat, they might create a taxonomy that is different. There's no, fixed taxonomy of functions, but I want to suggest that these 6 functions, these broad categories, absolutely apply in space. The first one is what coordination, let me just say that each one of these has probably 100 subcategories. So before people start chatting about that, I just want to acknowledge that. And tonight in my class, Global Cyber Policy, we're going to be talking about that top one and, the many, many different functions. So if any students are on this webinar, we'll definitely enjoy discussing that. But these are high-level categories with lots of subcategories. And what I want to do is discuss the functions through the lens of the Earth Internet, mentioning some of the specific tasks, mentioning some of the key institutional actors, and then describing how it's relevant in space, as I'm coming to understand it at this early point. So the first has to be, in my mind, control of critical internet resources. I use the word control I wrote down the word administration, so you can sense that there's a tension there. Because identifiers have to be unique, I was going to use the word globally unique. We'll talk about the Earth Internet. Someone has always had to manage the distribution and the allocation of these resources. So what does this include? It includes on the Earth, certainly domain names, internet addresses. I would add autonomous system numbers that identify networks, or more accurately, routing domains, and protocol numbers I would include in that. And then it would include the systems that administer this and that translate, for example, human readable domain names into IP addresses or internet addresses. I'm, of course, talking about the domain name system. And there are so many functions within that. There's the assignment of names, the allocation and the assignment of numbers. There's protocol number assignment, resolving DNS queries, securing all of this, operating the root servers, authorizing changes to the root zone file, managing the root zone file, resolving, in the case of domain names, domain name trademark disputes. So there are many, many others. These are carried out by not one institution, but by a lot of institutions. Of course, IANA, the IANA functions within ICANN, the Internet Corporation for Assigned Names and Numbers, but also regional internet registries that allocate addresses in their respective areas, the server operators, the DNS registries, and then those that are trademark dispute resolution providers. I could go on and on. There's so many institutions involved in this. Now, this is all quite different from government administration. The solar system internet will have commensurate requirements for unique identifiers for addressing of nodes, of data, of regions, eventually for network domains, among others. And already there are some registries for node numbers. ICANN, there's the Space Assigned Numbers Authority under the auspices of the Consultative Committee. So there will likely have to be an authoritative source. I'll just put that out there as a provocation. This will have to be worked out to have unique numbers and coordination of this. So this is it's also a very different architecture. It has to move because of some of those constraints that I mentioned earlier, from a client-server model to delay-tolerant approaches, the bundle protocol that so many are working on, perhaps the bundle protocol stack, perhaps replaces the internet protocol. But what happens to the domain name system? So the back and forth that happens with the DNS query lookups, I'm assuming is not tenable. I'm not certain about that. I'm assuming it's not tenable over the long space distances because of the latency. So that is something also that I wanted to flag as a possible architectural change. So this will have to be architecturally worked out, which gets into the standard setting function. This is a core function of internet governance on the Earth. It will be one of the first and most core functions of internet governance in space. Of course, I'm talking about shared interoperability specifications that enable all dimensions of information exchange. I'll just mention a few from encryption, compression, formatting, encoding, authenticating, error detection. These are household words on the Earth, and sometimes people don't even realize that standards like Wi-Fi and HTTPS and Bluetooth and maybe a JPEG, a compression format for image. So there are all kinds of standards. And the internet protocol and its surrounding architecture are primary examples of standards in the internet, and there are others as well. Of course, the Internet Engineering Task Force is one of the key institutions responsible for internet protocols. But there are others doing other things that are very important too. The World Wide Web Consortium, the ITU, the IEEE, ISO, and many, many acronyms. I'm sorry there are so many acronyms in this space, but that's just the way it is. The logic and the constitution of many of these standards on the terrestrial internet extend into space. So as is the question of what body will have ultimate change control over deep space networking standards. So these standards are already underway, to the DTN standards, both in the Internet Engineering Task Force and also some in the consultative committee of ISO in this area, and in other forums. It's starting to be a discussion point in many venues. So this will be a very important part of internet governance in space. And I wanted to point out that previous Academy talks have addressed standardization in great detail if someone's interested. Doesn't need to be said that cybersecurity governance is a critical part of both the Earth Internet and will be of the solar system internet. This is an area probably with the most overlap, although the latency of long distance transmissions will require, I would assume, some architectural changes, maybe some new security frameworks for space networks, specialized computer emergency response teams, CERTs and CSERTs. This is incredibly important. So private industry is, let me put it this way for the Earth Internet. The cyber domain is often thought of as a government domain, but cybersecurity governance on Earth is actually highly privatized because the onus falls upon the private companies that own and operate networks and systems, including the strategies and corporate compliance and corporate governance of large end users. So all firms think of themselves as tech firms now, whether you're a financial services company or a transportation company. And so cybersecurity is a very important part of that, as well as what governments do and what we all do. So a big part of cybersecurity governance around the internet is, of course, securing the core infrastructure of the internet, not just the kinds of things that I just mentioned. So the routing, the DNS, authenticating websites, using public key cryptography and trusted third-party certificate authorities, the authentication of handoffs among network operators. These are all functions that will have to be worked out in space. And I could say a lot more about that, but in the interest of time, I want to mention something very important about interconnection. This is an area that might actually be a little bit different, at least initially. Why is that? Well, on the Earth, private networks at this point in the evolution of the internet that run the networks, and they interconnect and make private contractual agreements to connect through peering agreements and transit agreements, whether bilaterally or at internet exchange points. So there's not a great deal of transparency in these agreements because they're private contractual agreements. And there's always been a tension around this about who gets to innovate and connect into the network, and tensions around private rights and anti-competitive practices. So the solar system internet seems to be, or will emanate initially from national space programs. It kind of reminds me of the early ARPANET. And that provides, I would think, an opportunity to have more well-planned out interconnection, a more well-planned out interconnection regime with greater transparency. And my understanding is that contact plans is the nomenclature for these emerging plans to interconnect. So just really quickly, the policy role of private intermediaries, that's one of the most consequential points of governance, content moderation decisions on Earth, privacy policies, and other forms of private ordering. This will likely be an issue in space as well, but one that probably will come after many of these other layers mentioned here. The role of governments in space, internet governance will be critical. It will be different. So what is the major difference? How would you answer what is the major difference between terrestrial internet governance and the role of traditional governments versus the solar system internet? Well, on Earth, governments enforce laws within their own borders, such as laws on speech rights, defamation, illegal content, privacy, encryption strength, intellectual property rights, a long list. So, and that is the case. And it's always important to say that governments, and please remember that governments, unfortunately, also disrupt networks and content, outages, censorship, invasive surveillance, if you think about especially about the global context, and sometimes carry out policies that are intended to carry out a governance function, but really disrupt the internet in various ways, like data localization laws, in my opinion, local redirection in the DNS, tampering with encryption strength, and a whole host of things. But the big difference in space will be this disruption in sovereignty and jurisdiction. So putting this all together, some functions will be similar, much redesign is necessary, and institutional oversight tensions will have to unfold as things start to work and be worked out. So I wanted to conclude, Jim, with just putting up a slide with some, what I think I kind of did this. Jim, how long was I muted for? I'm not sure how that happened.
You just dropped out for about 5 seconds.
Okay. So I wanted to end with, thank you for whoever unmuted me. I wanted to end by, just off the top of my head, presenting some insights for space governance from the history of how the terrestrial internet governance regime has worked out. So how many is this? 11. It's just some food for thought. One is that a common numbering system will be necessary for success and to achieve reachability and interoperability, but that because identifiers are so crucial, finite, and a point of architectural control, conflicts will likely emerge in the same way that this has historically been one of the conflict areas of the terrestrial internet. You can also see that I've added quite a few about standardization. I want to just suggest that the solar system should interoperate with the classical internet, avoiding problems that have ensued in, like, for example, the lack of backward compatibility between IPv4 and IPv6. I want to mention that avoiding fragmentation requires eventually standards harmonization as these standards innovations occur. And what we've seen in other areas, like in the Internet of Things, is that we've had multiple competing standards, regimes, and organizations. And sometimes what comes along with that is proprietary enclosure. So that leads into the next one, that open standards will be necessary, open standards now for private investment later. And historically, open standards have shaped economic conditions, competition, economic liberty, the freedom to innovate. Because if Jim and I decide and we're not going to be a chief architect at NASA and a professor anymore, and we start a company, we would want to be assured that the products we develop will be able to interoperate and be compatible with other products. That's why we would invest in it. So that will be important in this domain as well. So two others about standards. Standardization does not assure implementation. So we've seen that many times over the years, and I just wanted to flag that there are other things that need to happen in order for standardization to become implemented. And then standardization in this space may become highly politicized because of the security and economic stakes. And especially when new nation states seek to gain some advantage. So this has happened throughout the history of the internet, and it should happen here too. What are some other themes? I'll toss out just a few more. Another dominant theme in internet governance will likely convey, and that is that infrastructure is always co-opted, and it probably will be co-opted as a proxy for political power. In the same way that the DNS on Earth is regularly co-opted for content control, such as carrying out political censorship or in various other reasons, so too will infrastructure in space possibly be co-opted to become a proxy for, I don't know if we can call it this, helio-political power. Another insight is that tensions will exist between multilateral versus multi-stakeholder models. This is probably the most interesting area, and maybe a webinar in and of itself. Space governance is and has primarily been multilateral. Internet governance is multi-stakeholder. So what can go wrong? I mean, it's two different communities that have to come together. And really, this is a continuation of conditions on the Earth, where throughout internet governance history, there have been two, if I can say, incommensurable worldviews about how technology should be governed in the internet space. A multilateral and cyber sovereignty model on one hand versus a private sector-led so-called multi-stakeholder model on the other. So that is definitely something I wanted to flag. And the political lesson of moving on to the next one, that network security will converge and diverge with national security. I want to make this point really strongly. The strange distinction between cyber and internet on Earth, which makes little engineering sense, will carry over into space, with one group entirely focused on national security and cyber war. Yet the same community often wants to weaken network security to enable other paradigmatic functions of governments like intelligence gathering and surveillance, and to carry out law enforcement functions. So this tension may already exist in discussions about the solar system internet. If it doesn't, it probably will. So, and finally, I always like to end by saying cybersecurity becomes the great human rights issue of our time. In this arena, it will be confidentiality and integrity, integrity of information, authentication of nodes, and authentication of trust relationships between networks. They all require strong cybersecurity. So that's the technical way of saying it. The internet governance way of saying it is that national security, privacy, the economy, and the very trust architectures underlying the communication systems will depend on cybersecurity. So finally, let me just say in conclusion that I'm personally excited about the efforts that are underway, not only around the long-term solar system internet, but also the more immediate ones, the LunaNet, Moonlight, and the Earth satellite space race, things closer to Earth. I've seen more SpaceX launches than I could possibly recount. I love the autonomous drone ships. I long ago witnessed a nighttime space shuttle launch. My father was a radio gunner in the Dauntless dive bomber in the 1st Marine Air Wing in the South Pacific in World War II. I love air travel of all kinds. And if you think about that, what I just said, it reminds us all that technology evolves. In the same way that technology changes, so must technology governance evolve to meet the moment. So internet governance is not fixed any more than technology is fixed, and we have to be open to see where it needs to go. So thank you so very much for inviting me, and thank you for listening. I will turn it over to Jim.
All right, thanks, Laura. So my first reaction is, wow, what the hell have I gotten myself into? You've just enumerated so many problems that I haven't begun to think about yet. There's obviously a long road ahead of us, and it'll take a long time to figure out all of the answers to the questions you've just posed, and that's only the tip of the iceberg, I'm sure. And I'm sure you've singled out some of the most interesting and significant ones. But if we could go back momentarily to your slide on challenges, let me make a couple of comments, and then we've got maybe 2 minutes to answer a couple of the questions that have built up in the Q&A box. And it's clear that we're going to have to work on answering the complex questions that have been answered offline and continue this conversation after the webinar today. So could we, I don't know what slide number that was, but whatever your slide on challenges, you started by mentioning space debris. So one of that's the one, thank you. Space debris is the tip of the iceberg there. It's the immediate challenge to look at the rocks flying around in space. This actually becomes one element of a larger topic, which is space traffic management, so that we have to worry about not only dodging the bits of debris floating around in space, but all of the other spacecraft, many of which are active, under control, but also contribute to the debris problem. And so a direct counterpart can be made between this and air traffic control. Air traffic control wound up generating the International Civil Aviation Organization, or ICAO, as a governing organization in order to put sanity into flight between countries. And a similar situation may wind up occurring in space, where for safety of navigation in space, just as safety of flight in the airspace of the Earth, we have to collaborate so that we can safely fly around. And that's just beginning. There was a first step in that direction put in under the previous administration, but resulted in a space policy that wasn't funded by Congress, and so remains an open question. If I jump to time inconsistencies, I would point out that as part of the expanded services that we're talking about with LunaNet, we're not only including communication and networking, we're also including position, navigation, and timing services. So think of LunaNet as being the sum of the internet and GPS or Galileo.
Jim, quick question. For those that may not be familiar with the time inconsistency problem, how would you describe it?
So due to relativity, we can tell that the moon operates at a slightly different time standard than the Earth because it's in a different gravity well. And it's also a lumpier body, so it has more gravitational inconsistency than flying around in orbit around the Earth. So the GPS has to apply relativistic corrections, or we would be off by up to 32 microseconds per day on the time disseminated by GPS. And there would be even more inconsistency at the moon. Our preliminary analysis shows that there could be up to 72 microseconds per day difference in the timing between the Earth and the moon. So what we're starting to do is develop a new lunar reference system in parallel to the terrestrial reference system, and a new lunar time standard that would be independent and parallel to the time standard around the Earth. And then we'll have to coordinate the differences between the two. So it will be a translation between an offset or correction factor between Earth time and moon time. And that will propagate into other celestial bodies in the solar system. But we're working that will also result in a set of standards at the international level. And then the last thing to mention here on the sovereignty upended, one of the interesting implications of the Outer Space Treaty is that there's no real estate starting with the moon, and if no nation can claim territory on a celestial body, which is what that treaty states, then anybody can land anywhere and set up whatever they want to do. So since the nations that are interested in pursuing the moon right now are likely headed for the South Polar region, because it appears to be where there are deposits of water ice, which is an incredibly valuable resource, we may literally face the very early trial conditions here, where we and other countries may go to nearly the same location at the South Pole of the moon and get into competition over the same resources. And you could literally land next to each other in nearly a literal sense, or within a few kilometers. Now we can either do that peacefully, so that, you know, I can take my rover and drive over to the Chinese space station and borrow a cup of sugar, or we might, you know, wind up with a more contentious situation, and communication and navigation functions would clearly be a benefit there if we're all working on the same international standards. So we include everybody when we're talking about setting this stuff up.
Well, I think it's really wonderful how different communities like internet architecture, space innovations and internet governance, have come together around some of these, not only the events, but there's a lot of material that is available through the IPNSIG Academy. And Jim, I think you wanted to mention that. This slide is here.
Yeah, I think that's my cue. Thanks, Laura. So our hour is up, unfortunately. I'm sure everybody feels like me that we barely scratched the surface. This is a topic that could take a long time to discuss. We do want to mention that the IPNSIG Academy has a program for the rest of this year. You can see some of our past topics and a couple of our upcoming topics this year at the bottom of the list. If you're interested in hearing about a particular topic, please feel free to send us an email and suggest it. If you're interested in this, please send us an email to join the IPNSIG and become a member, and we'll enroll you. We have over 900 members today, so you can send a message to membership@ipnsig.org and join the excitement. And so while that concludes today's session, I promise to work with Laura and go back and answer all the questions that we received. And that should be our, this will ultimately be posted to the IPNSIG website, the video and the follow-on response to all of the questions. So I'd like to thank everybody for joining today and look forward to the next version of the IPN Academy keynote presentation.
Thank you so much.
Thank you, Laura. We appreciate your talking to us today. This has been highly educational and informative. I'm going to have to go back and rewatch this whole thing myself. So, very thought-provoking. Thank you very much.
Thanks for joining us.
And